Dear students, welcome to my 6th class on module 1 Laplace transforms. So in my previous lecture video I explained about inverse Laplace transform and few problems on inverse Laplace transform also. So in this lecture video we shall discuss few more problems on the inverse Laplace transforms only. Example number 5. Find the inverse Laplace transform of k divided by s plus a into s plus b. So in this problem we shall treat that k as a constant. So now I am going to represent this problem in terms of partial fractions first. So like after finding the values of a and b, we will be applying Laplace inverse. So first write the equation in terms of partial fractions. That is 1 by s plus a into s plus b will be equal to a divided by s plus a plus b divided by s plus b. So now by taking LCM, I am just shifting this s plus a into s plus b to RHS. So we will be getting a into s plus b divided by s plus a plus b into s plus b divided by s plus b. So after simplifying this, we got the equation like 1 is equal to a into s plus b into s plus a. So now our job is to find the values of capital A and capital B. So to find capital A, we have to make b 0. To find capital B, we have to make a 0. So now I am going to find the value of capital A. So for that I am going to replace s is equal to minus a. So if I replace s is equal to minus a in this equation, the b term completely gets eliminated. We can find the value of a. So we got a is equal to 1 by b minus a after replacing s is equal to minus a in this equation. Similarly, to find capital B, I am going to replace s is equal to minus b in the above expression. So after replacing s is equal to minus b, so this term gets vanished. So we got b is equal to 1 by a minus b. So now these constants a and b I am going to replace in the above expression here. So we got 1 by s plus a into s plus b will be equal to 1 by b minus a into 1 by s plus a minus 1 by s plus b. So the constant I am taking common factor as 1 by b minus a. So we got this expression. So now I am going to take k on both sides of the equation and applying Laplace inverse. So we got Laplace inverse of k divided by s plus a into s plus b will be equal to k divided by b minus a into Laplace inverse of 1 by s plus a minus Laplace inverse of 1 by s plus b. So this constant k by b minus a will keep as it is. Laplace inverse of 1 by s plus a is e power minus at and Laplace inverse of 1 by s plus b is e power minus bt. This is the required solution for the given problem, k by s plus a into s plus b. Example number 6. Find the inverse Laplace transform of s square plus 2s minus 4 divided by s square plus 9 into s minus 5. So same thing in this problem also. So first we shall represent the given problem in terms of partial fraction method. So consider s square plus 2s minus 4 by s square plus 9 into s minus 5. So this will be equal to a divided by this single term I am taking here. For this square term, so make the equation like this, that is bs plus 3 divided by s square plus 9. So now take LCM, shift this entire term to a into this equation. So after simplifying this, we got a into s square plus 9 plus bs plus c into s minus 5 is equal to s square plus 2s minus 4 we got. Okay, now our job is to find the values of capital A, capital B, capital C. So for that, first I am going to replace s is equal to 5. Okay, if I replace s is equal to 5, this complete term gets vanished. We can able to find the value of a. So after replacing s is equal to 5, so we will be getting a into 25 plus 9, this is 0, is equal to 25 plus 10 minus 4. So after simplifying this, we got a is equal to 31 by 34. Now I am going to equate the powers of s square. So taking all s square powers on both sides, we got b is equal to 3 by 34, and also by the constant terms we'll be getting c is equal to 83 by 84. So now all this ABC value I am going to replace in the above expression here. So that so we got the equation like s square plus 2s minus 4 by s square plus 9 into s minus 5 will be equal to 31 by 34 into 1 by s minus 5 plus 3 by 34s plus 83 by 84 divided by s square plus 9 we got. Okay, now I am going to apply Laplace inverse on both the sides of the equation. So we got Laplace inverse of s square plus 2s minus 4 divided by s square plus 9 into s minus 5. So it will be equal to Laplace inverse of 31 by 34 into 1 by s minus 5 plus 1 by 34 into 3s plus 83 by s square plus 9. The constant 1 by 34 I am taking outside from the entire equation and applying the linearity property. We got 31 by 34 into Laplace inverse of 1 by s minus 5 plus 3 by 34 into Laplace inverse of s by s square plus 9 plus 83 by 34 into Laplace inverse of s by s square plus 9. So now applying the standard formulas of inverse Laplace transform. So we got 31 by 34 e power 5t plus 3 by 34 cos 3t plus 83 by 34 into 1 by 3 sin 3t is the required solution. Example number 7. Find the inverse Laplace transform of cot inverse of s by a. Okay. So now to solve this problem, so first choose the function f of s is equal to cot inverse of s by a. I'm going to find the f dash value. So that is finding d by ds on both the sides. So we got f dash of s is equal to minus of a by a square plus s square. So now for this function, I'm going to apply the inverse Laplace transform. That is Laplace inverse of f dash of s will be equal to minus Laplace inverse of a by s square plus a square. This will be equal to minus sin 80. So now Laplace inverse of cot inverse of s by a will be equal to minus 1 by t into minus sin 80. So it will be equal to sin 80 by t we got. So now, to solve the next problems, the formulas will be like Laplace transform of integration 0 to t f of t dt will be equal to capital F of s by s we can use. So in the same way that Laplace inverse of capital F by s will be equal to integral 0 to t f of t dt. It will be equal to integral 0 to t Laplace inverse of f of s dt. So this formula we have to use for this kind of functions. Example number 8. Find the inverse Laplace transform of 4s plus 2 divided by s minus 1 whole square into s plus 2. So now same thing here also, I am going to represent this equation in terms of partial fractions. So I am going to rewrite this 4s plus 2 by s minus 1 whole square into s plus 2 as a divided by s minus 1 plus b by s minus 1 whole square plus c by s plus 2. So now taking LCM of this equation, we will be getting a into s plus 2 s minus 1 plus b into s plus 2 plus c into s minus 1 whole square will be equal to 4s plus 5. So now our job is to find the values of the constants a, b, c. So to find the value of a, we have to make b and c 0. To find b, we have to make a and c 0. To find c, we have to make a and b 0. Okay, I will replace s is equal to 1. So we'll be getting a is equal to 1 by 3. Similarly, if s is equal to 2, we can find the value of b is equal to 3. And if s is equal to 0, we can find the value of c is equal to minus 1 by 3. So now this all the values I am going to replace in the previous equation. So we'll be getting Laplace inverse of 4s plus 5 divided by s minus 1 whole square into s plus 2 will be equal to Laplace inverse of 1 by 3 into 1 by s minus 1 plus 3 into 1 by s minus 1 whole square minus 1 by 3 into 1 by s plus 2. So by applying the linearity property, we can rewrite the equation as 1 by 3 into Laplace inverse of 1 by s minus 1 plus 3 into Laplace inverse of s minus 1 whole square minus 1 by 3 into Laplace inverse of 1 by s plus 2. So therefore, we can write the equation as 1 by 3 e power t plus 3 e power t Laplace inverse of 1 by s square minus 1 by 3 into e power minus 2t. So finally, we got the equation like 1 by 3 e power t plus 3t e power t minus 1 by 3 e power minus 2t is the required solution for the given problem. Okay, in the next lecture video, the problems on convolution theorem will be learning. Thank you.